Good afternoon. Today we are going to discuss about frequency demodulation. What is meant by frequency demodulation? The process of extracting the modulating signal from the modulated signal is known as frequency demodulation or frequency detection. There are two steps in frequency demodulation. The first step is convert FM into corresponding AM. That means convert frequency modulated signal into corresponding amplitude modulated signal. And second step is extract the modulating signal from AM by using envelope detector. Then requirements of Fm Demodulator. Convert frequency variations into amplitude variations. Conversion must be linear and efficient, insensitive to amplitude changes, not be too critical in its adjustment and operation. These are the requirements of FM demodulator. Next is the types of FM detectors. Basically, FM detectors are classified into two types: frequency discriminators and phase discriminators. The first type, frequency discriminators, are further classified into two types or two methods. One is the single tuned discriminator or slope detector, and second one is the stagger tuned discriminator or balanced slope detector. Then the phase discriminators are two methods. One is the Foster-Seeley discriminator and second one is the ratio detector. Now we are first going to discuss about single tuned discriminator or simply known as the slope detector. So the slope detector consists of two circuits, slope circuit and the envelope detector. The input given to the slope circuit is the FM waveform, frequency modulated signal. The slope circuit convert the FM into corresponding AM, amplitude modulated signal. That amplitude modulated signal is given as an input to the second circuit's envelope detector. The envelope detector extract the modulating signal from the AM signal, amplitude modulated signal. Here, why the detector is known as the envelope detector means the detector detect the or extract the envelope of the input AM. That's why it is known as the envelope detector. The envelope of AM is equal to the amplitude modulating signal. Okay, so it extract the envelope of AM. That's why it is known as the envelope detector. So this is the corresponding circuit diagram of slope detector, simple slope detector. It consists of, the slope circuit consists of tuned circuit. Okay, the tuned circuit is tuned to input. Primary end of this tuned circuit is tuned to frequency FC. FC means center frequency. Center frequency means the resonant frequency. What is mean by resonant frequency? Means the frequency at which output voltage is maximum. Okay, so here the input primary end is tuned to frequency FC. Then the secondary is tuned to frequency FC plus del F, which is more than the input frequency, center frequency FC. Input is the FM waveform. Okay, the input FM is the frequency modulated waveform is given as an input to the primary end. So depending upon the frequency changes in the input, the output will be increased or decreased. That is, see that. See, the input frequency, suppose above FC means the changes because your input is the FM waveform. The FM waveform, the varying parameter is the frequency. Amplitude remains constant. There is no change in the amplitude. So, if your input frequency is above FC means the output V naught is increased. If it is decreased, input frequency value is below Fc means the output V naught is decreases. Corresponding characteristics. Okay, see the transfer characteristics. So at the center frequency, output is maximum. Then output is increased or decreased below or below Fc or above Fc. Okay, deviates from the Fc. From that, we have to extract the input signal. Limitations of slope detector. What are the drawbacks in the slope detector? It is inefficient as it is linear in very limited frequency range. Then it reacts to all amplitude changes. It is relatively difficult to tune as tuned circuit must be tuned to different frequency than carrier frequency. So these are the limitations in the slope detector.